Next, we are going to look at the graph of an equation. So we're going to return to the Cartesian coordinate system, okay? And what we're going to see here is we are given a little bit of a context. So height of a ball at time x, okay, instead of t. And so we're given that the height of the ball, which is y, so this is height, and both of these x's represent time. Okay, and all we want to do is generate a graph of the equation by plotting coordinates. Okay, by plotting solutions x, y to this equation, and then we're going to plot it on this grid. Okay, that's just fine. Okay, so here's x and here's y. All right. So now to complete this table, if I have an x value, I'm just going to substitute it in and see what I get. So I put in 0. Okay, that's really boring. I get 0. Okay, and now, so for example, I would substitute in 2. Okay, that'd be 32. So I'm just going to do the math here. 32, and then we have 2 squared, so that's 4 times 3 is 12. So okay, and then so that's 20. Okay, when I do the subtraction. Okay, now you'll have to do 5 on your own. Next, the situation changes a little bit. I need to find which x value corresponds to 4, so that means my equation changes just a little bit. I have 4 now for y is equal to 16x minus 3x squared, and so then I would, get the 4 to the other side, so I have 0 is equal to, and then if you want to rearrange, minus 3x plus 16x minus 4, and now with this, I would use the quadratic formula to solve this. So I did that off screen here, and when I did, I actually got 2 values of x. I got, 0. Approximately, when I round to 2 decimal places, 0.26, and also 5.1-ish. Well, actually, okay, we'll do 5.07. Okay, but so I would get 2 values of x, and I would separate that into 2 points. Okay, so now what I want you to do is figure out figure out these last 2 boxes. All right, and resume the video when you're ready. So I completed this again by pausing the video, and so now what I'm going to do is I'm going to try to create a graph of what this is going to look like without using a graphing calculator or any other graphing utility right now. So I'm just going to put, 0, 0 in here. So I'm going to plot the point 0, 0, include a label. I do need you to include the labels. And then I'm going to, just for scaling purposes, I'm going to go up by 4s. So and I'm going to label this 4, 8, 12, 16, 20, 24, and then I'll go up to 30, and I'll pause there. Okay, so then when y is 4, I'm at roughly 0.26 for x. So 0.26 comma 4. Okay, and then this I can also read as, over at 5, I'm going to go over by 1s on the x-axis. So 1, 2, 3, 4, 5, and I'm going to include just some markers on here so that I know where I'm at. 4, I'll go by 2s. Okay, or label every 2. Okay, so then I'm at 5, and then also that 4, so 5.07 comma 4. Okay, now I'm going to continue just plotting these points. 2, I'm at 20, so I'm up here ish. So 2, 20, and then also at 3.3, I'm at 20, so right about there, 3.3, comma, 20, okay, and then lastly, I'm at 5, 5, so that's going to be right about there, so this is going to be 5, 5. Okay, now, to generate a graph, what I'm going to do is, honestly, at this point, do my best, okay? I think, so time can't go past 0, but what I'm seeing so far is that it's going to look something like this, and then I'm just going to kind of try to connect the dots the best that I can, and it's going to continue on something like that. Okay, and so right now it's not too precise. What I would actually do is, take find more values of x and see what values of y I get. Okay, and now for part B, estimate when the ball is at its maximum height. Well, based on my graph, so it looks to be kind of like halfway between here or something. So maybe like, I don't know, 2.5. So when x is equal to 2.5 or so. Okay, and now if you haven't used Desmos, it's a lovely tool, and I encourage you to use it. But we're going to get a more precise picture using Desmos. And so here's the website. You can just go to desmos.com and then click on the calculator, or you can guess desmos.com/calculator. And sure, we'll keep those. And so I'm just going to open up a browser here, and I actually have it bookmarked. So Desmos. And now in here, it's super easy to use. I recommend playing around with it. It's actually kind of fun. So I'm just going to enter the equation y is equal to 16x minus 3x squared. And here you go. You might have to zoom out a little bit and recenter things. But so we can see that many of our points still hold. Okay, we had that 5, 5, and right, we had at 20 we had 2 and 3.3, and now if I look at the maximum, I can actually click on the graph and click on various places, and it'll tell me the points there. So this maximum appears to be 2.66. So my guess wasn't too far off previously, but play around with Desmos, and there is also an app for Desmos, and it's also equally easy to use. So try to get some practice with that.